All right. And we're back. So welcome to the third meeting of the Web3 Teacher training track. Today we're going through topic 2, exploring smart contracts. So let's just whip through this little slideshow real quick. There we go. And yeah, all right, so we're going to talk about exploring smart contracts by diving into some real life smart contracts. So we talked a little bit about smart contracts in last session, about how you can write code that's executed on the blockchain and how that code is unique, kind of, in that it has to be, for example, deterministic, and sometimes there are these domain-specific programming languages that you have to use, etc., etc. And so let's talk about one of these super popular use cases of smart contracts, and that is implementing another coin, like basically another cryptocurrency, on top of Ethereum, right? So these come in the form of token standards because there's a standardized way for implementing, another coin, essentially, like a ledger technology on top of Ethereum. So there are a bunch of different token standards, and here are a few of them: ERC20, ERC721, ERC777, and 1155. We're going to be going through ERC20 and 721 today, because those are by far the most popular versions for, or most popular standards for fungible and non-fungible tokens. But totally feel free to look up the standards for 777 and 1155 if you're interested, because they have their own special features as well. So ERC stands for Ethereum Request for Comments, because we're always trying to make sure that these standards are as good as they can possibly be. So let's talk a little bit about fungibility. We have these two different types of token standards. ERC20 is fungible tokens. ERC721 is non-fungible tokens. So they're kind of like two sides of a coin, right? Fungibility, if a token or an asset is fungible, that means that you can swap any one asset with another asset in the same group, and it's like nothing changed, right? So it's like dollars. If I have $1 bill and you have a dollar bill and we trade dollar bills, effectively no value has changed hands. A dollar is a dollar. It doesn't matter what dollar it is. It's a dollar. Whereas if something is not fungible, that would be something more like an original piece of artwork, right? There's only one Mona Lisa, and it's not that you own a painting, it's that the Mona Lisa is the Mona Lisa. There's nothing that you can compare the Mona Lisa to, because there's only one, and it's unique, and it's special because it's unique, or in large capacity because it's unique. There's only one. So that would be an example of a non-fungible asset. So let's talk about ERC20 fungible tokens. So pretty much this is exactly what you think of, just like dollars, right? If you have a bank ledger or something like that, you just have a sheet, a list of balances, right? Accounts, and how much that account is worth. So Alice's account has maybe $40 and Bob's account has $30. And if you're just going to, transfer these completely fungible assets, this asset is literally just a number on maybe a number in a computer, right? It doesn't matter, if incrementing by 1 is just incrementing by 1. It's the same 1. It doesn't matter where that 1 came from. All right, hold on. So I'll switch back here. Okay, so let's talk a little bit about the information that is provided by the ERC20 standard. So some of these, like the token name and symbol, are optional, and then you have like total supply and decimals. Those are just some properties, some metadata about the token that specifies how it should be displayed, how people can use it, and if there's a total supply, then you can kind of figure out maybe how much your token might be worth. So, did everyone have a chance to read through the ERC20 token standard, or should we go through that again now? Anyone want to go through it right now? All right, perfect. Okay, so there should be a link to it. Yes, right here. All right, so here we have our ERC20 token standard. Again, you can find all this right here in the website link there. Perfect. So let's go through this really quick. As I mentioned, we have the name. Let me zoom in a little bit. That's too much. There we go. All right. So we have, for example, name, and it says that's optional. Name just returns the name of your token, my token. The symbol, that would be like BTC for Bitcoin, except Bitcoin is its own chain. It's not implemented on top as like an ERC20 or anything. So yeah, name would be like my token, and then here is the 3-letter abbreviation, the symbol for it. Decimals, this just kind of tells you, since we are going to store the quantity of tokens that you have as an integer, the decimals just says, okay, how many times do you move the decimal point over in that integer to get the effectively fractional version of the value of your token. So the way this works in Ethereum is Ethereum has 18 decimals, and that means that 1 ETH token is actually 1 times 10 to the 18 of the smallest indivisible unit of Ethereum, which is called Wei. I think that's how you pronounce it, W-E-I, Wei. And that's kind of how decimals work. Then we have total supply, how many tokens are available, and then the balance of method here. You're going to pass in the address of, well, any address, and it will tell you, okay, I have, this contract thinks that this address is entitled to, whatever integer number of tokens. Then we have a transfer function, which is going to transfer tokens to an address. We have a transfer from, which we'll talk about in a bit, approve and allowance. We'll talk about those in a bit. And that is pretty much all we need to look at in the ERC20 standard right now. Right, so ERC20 is a token standard, and what that means is any token, any contract can claim to implement this standard, and it doesn't specify a specific implementation. It just says this is the interface that must be supported in order for a token to be considered ERC20. So there is no one holy grail, one perfect given implementation of ERC20. All that this tells you is an ERC20 token must provide a function that matches this signature and returns the total token supply. It must have a function that matches this signature and returns the account balance of, and does these particular descriptions as they're described in English. But how the contract does it is not specified. And that gives you flexibility, because then you can say, okay, I have an ERC20 token that is fully compliant with the standard and also has special features, right? Because if you were tied to a specific implementation of this standard, there wouldn't be room for, your own modifications or improvements or something like that. So we'll go through a couple different implementations of these various standards that we're talking about today, and you'll kind of hopefully get a sense of what that implies. All right, so that is kind of going through the ERC20 token standard. Now, given what we've seen, let's think about this scenario here. So Alice sends some ERC20 tokens to a contract's address. Let's look at this transfer method again, okay? So function transfer, it takes in 2 arguments, 2 and value. Okay, and this is the data type here, and this is just the name of the variable. Data type, name of the variable. Okay, so what this transfer function is supposed to do is take tokens that are currently take value number of tokens that are currently assigned to the address of whoever calls this function, and reassign that value to the address here, this to address. And if you think about this, how might a smart contract implement this sort of balance mapping, right? So address has X number of tokens, right? How might a contract implement that sort of data structure? Just throw out any suggestions. And if you've read some implementations of ERC20, this should be a really simple answer. Any ideas? Or if you have taken like a data structures course, if you want to map a one value to another value, or a key value to a value, a key to a value, and the keys are unique, what type of data structure would you probably be using? Hash table? Yeah, that is exactly what you might be using. In Solidity, they're not called hash tables, but they work basically the same way. They're called just mappings. And that is exactly right. That is exactly the correct answer. Hash table, hash map, a map, a dictionary, all of these are an associative array. All of these are names for very similar types of data structures, right? So, what does that mean when, if you were to say, okay, here it is. If you were to say, I'm going to send some ERC20 tokens to a contract's address, what are we really saying when we call this transfer function? We're just changing two entries in a hash map, essentially, right? So, can the contract use the tokens? This is not a trick question. Yes, that is correct. The contract can use the tokens. However, does the contract know whether it has tokens to use immediately after this transfer function is called? Does it know? And how could it know if it does, and why doesn't it know if it doesn't? Any ideas? Okay, but we need to think about who is calling this function. The contract, this to address is not the one calling this function, so it's not the one receiving the return. But that would be a good way to check if we were both the sender and the receiver. You could. That would be kind of expensive. But yeah, that could work. So essentially, this, I mean, that is an expensive or potentially slow or difficult to optimize solution to the problem if we're just checking every single block, right? I mean, it would work, but it is kind of a problem with our current, our understanding of the ERC20 token up to this point. And so that's where these transfer from and approve and allowance functions are going to come in handy, because the contract doesn't know right away whether it has tokens that it can use, right? And also Alice doesn't know that the contract knows how to handle those tokens. So the solution that the ERC20 standard proposes to this sort of problem is allowances. That slide didn't need to be there for more than a second. And the idea behind allowances is to allow an address to transfer some of your tokens, but not actually transferring them yet. And then that kind of solves the problem of you trying to transfer tokens to a contract that doesn't know how to handle ERC20 tokens, and then your ERC20 tokens are just lost forever because that contract will never be able to it will never be able to receive those tokens, right? So the allowances paradigm has these two steps. You allow an address to transfer some of your tokens, and then you tell the contract to transfer those tokens. And you can kind of do this, outside of the chain. So so let's go through how this would work. So we have this transfer from function here, and this is one that actually the contract that is receiving the tokens would probably call, and then it can access this success boolean here. So that's a key distinction between transfer and transfer from, is that transfer from, we can allow the receiver of these tokens to call transfer from, and then they can figure out whether it actually worked, right? So obviously we need to make sure that we're not just going to allow anyone to transfer any tokens from any address to any other address, because that would be silly. So we have this approve and allowance set of functions here, where a owner like Alice would call approve with the address of the contract and a limit of tokens that they're allowed to take. And then Alice would tell the contract to, like maybe via a web app or something like that, tell that contract to call this transfer from function here, and then the contract can verify that it has ERC20 tokens. And then this allowance function allows you to see how much allowance a address has remaining. So that's kind of how allowances work in ERC20. Of course, the problems are that it is still a two-step process, and there is a possibility for failure at every step. So you might, it is possible to, for your approve call, is it possible for an approve call to fail? I mean, probably. I guess it returns a success boolean, and then the transfer from can definitely fail. So let's take a look at one concrete implementation of the ERC20 token standard, which is from Open Zeppelin. These guys are pretty popular. They write pretty popular contracts that people like to derive their own contracts off of. So right away here, this is our mapping. Here, I'll zoom in so that, if you ever can't see something that's on my screen, if you need me to zoom in or something, just let me know. All right, so right away, here is our mapping, right? We're mapping addresses to integers. This is an unsigned integer that has 256 bits. So it's an unsigned 256-bit integer. Private access modifier, right? Does anyone have trouble reading this line of code here? Private is access modifier, which means that, so if, for example, this were public, another contract could call this balances thing here and view it. They wouldn't be able to modify it, but they would be able to view it. So it's not necessarily. Let's see, if we look at their balance of right here, this provides, now this is, I can't speak exactly to Open Zeppelin's coding practices here, but I think it is not a bad idea to write these getters functions for mappings like balance of, even if it is just this simple as this, just so that you can be absolutely sure and very clear with how the data inside your contract is controlled. So this effectively provides the same interface as saying public balances. They just decided to implement it this way, and this is compliant with the ERC20 standard. So that is how that works. All right, so anyone have issues reading this line of code here? This is saying we have a mapping that maps addresses to unsigned 256-bit integers, and this value is private, so not accessible to read by other contracts. Obviously, the entire blockchain is public, so you can figure out the state of any smart contract at any point in time, but other on-chain smart contracts will not be able to read this variable directly. And then that's just the name of the value. Allowances, this is a little more complicated data type here because we have a mapping that maps addresses to mappings, which map addresses to unsigned 256-bit integers. That was not probably a very clear way of saying what this does. Essentially what this does, in other words, I suppose, is it's going to map kind of a set of allowances, and this set of allowances says an address is allowed this much allowance and we have a set of allowances for each address. Hopefully that makes sense. And then these are just simple primitive values. Hopefully those are easy enough to understand. Yes. Yes, you can have a different allowance for every single other person. Yes. The nice thing about how mappings work is that just by declaring this data type, it's not going to immediately create empty entries for every single address, right? So this is not going to take up tons and tons of space immediately upon declaring it. It's kind of dynamically allocated in that respect. But this is just saying the structure of the data will be such that we will be able to have a set of allowances for every address, and each allowance says that an address is allowed up to X amount of ERC20 tokens. An allowance is a cap to the amount of tokens that a third-party address is allowed to spend from your account, or from your right. So say my balance in this ERC20 token is 20, and I give you an allowance of 5. That means that you are allowed to call transfer from on this smart contract with that means that you are allowed to call transfer from on the smart contract and transfer for up to 5 tokens from my ERC20 token or ERC20 account to a different address. So yes, and this would be 5. Yep. So it would be like my address is says 20, and then in balances, and then my address in allowances, the mapping for that maps to my address. Here, this contains your address, and this says 5. And then if we look at the implementation of transfer from here, So here, this is how we're accessing these pieces here, right? Message sender, that's you, right? So this is my address that you're putting here. This is any other address. It doesn't have to be yours, but you have to be the one sending the transaction. So then this finds out your current allowance. This is like an assertion, right? Although assert and require are different things, but it's not require like Node.js require. This is require like an assertion in a test. So if this condition here is false, it will kill the execution right there. Yep. So it requires that the current allowance is greater than or equal to the amount that you are attempting to transfer. And then there we go. Perfect. Awesome. Yep. All right. So we can keep going through this, but we are 30 minutes into the session right now. Do you guys, and here's the thing. So the way that this course is currently structured is we have 7 topics and we have 10 weeks or 10 sessions to go through all the rest of these topics. So we can kind of, so some of the topics can take 2 sessions. Do you guys want to go deeper into ERC20, or do you guys want to move on to ERC 721? All right. Anyone of an opposite opinion? Should we take a vote? Okay, cool. So then in lieu of going through these live contracts here, which, did I have that open? Yeah. Yeah, I just want to do a quick side note about these guys. I found these tokens here, these contracts on Etherscan just by scrolling through Etherscan more or less randomly. So these are not, like, I'm not recommending these as good projects or anything like that. These are just random tokens that I found that weren't too long, didn't seem to be too complicated, and implement the ERC20 token standard. So that's all that they are. They're not a recommendation or endorsement. All right, we should go through the allowance double withdrawal attack before we move on to 721. That is a specific kind of vulnerability in the way that this standard works that has to do with how allowances work. And it's kind of like a race condition, if you're familiar with race conditions. Here, I will just open this guy up here. Essentially, the idea behind the attack is Alice has approved Bob to use a certain value of tokens, right? And Bob has not used his entire allowance of Alice's tokens yet. And then Alice decides to change Bob's allowance of tokens. However, if Bob sees that Alice is changing his allowance, like sees the transaction go out to the Ethereum network literally from Alice's computer, and is able to send a transfer from transaction that hits the blockchain before Alice's approval transaction hits the blockchain, then Bob can spend the entire rest of his allowance and then get an entirely new allowance. So, does that explanation make sense? That is pretty much what this attack scenario here describes. Well, it's not. The way to fix it is, well, first of all, it's not going to happen all the time. It's only going to happen if you're using allowances and you have given an allowance to a malicious actor, right? And then the way to it depends. There are, I think the primary use case for allowances is as described previously when you want to transfer ERC20 tokens to a contract. But I think there are a number of different ways that people might use allowances, which is why, I mean, this is probably the most publicized vulnerability, kind of in scare quotes, I guess, in ERC20, because it's not, in my opinion, yes, it is a weakness in the standard, but it's not like a, we don't have to throw away the whole ERC20 token standard because of this. There just needs to be an extra step when using allowances, because the way to mitigate this vulnerability is quite simple. All you have to do is, instead of sending one approve function call, send two. The first one where you approve their allowance to be 0, and then the second where you approve their allowance to be the new value that you want it to be. So, and that's what it describes right here right here in the actual standard. Clients should make sure to create user interfaces in such a way that they set the allowance first to 0 before setting it to another value for the same spender, though the contract itself shouldn't enforce it, to ensure backwards compatibility. So that is kind of the biggest, best known vulnerability or attack vector on ERC20. It's called the allowance double withdrawal attack. I should probably zoom in here a little more. Can y'all see and read this fine along with me? All right, perfect. So let's move on to ERC721. And there are going to be a number of methods here that are familiar. So I'll just close out of all of these guys here. I suppose here, let me scroll through my slides here. Got through that. All right, ERC721. Now this one, because each token is non-fungible, right? Each token is unique. That means instead of mapping a address to a number of tokens that they own, you instead need to assign an owner to each token, right? Because each token is unique. Number 1 is unique. It's the only number 1 that there is. So that means that instead of mapping from address to quantity, we are mapping from token number to address. And if we look at an implementation of ERC721, like, again, OpenZeppelin, really like OpenZeppelin. Lots of contracts use their interfaces or libraries, and I think they wrote Safe Math as well, which is a popular library. I think so. I can't quite remember. Oh well. So here we have mapping from token ID to owner address. So we're going to map a number to an address, and those are our owners right there. And here they have a token count as well, just to say you own this many NFTs in this contract. And then you can map the token ID to an approved address. So you also have allowances in ERC721. It's just, you can't allow someone to send half of an NFT. You can either allow them to send the NFT or not allow them to send the NFT. So, all right. Let's see here. This particular contract is implementing another ERC called ERC165, which provides, it allows other contracts to detect whether a particular contract supports a ERC standard. So this so here you say you can detect that this contract supports ERC721, for example. Yep, and then we have our balance of. Let's see, we can go through the interface here and look at the implementation later. All right, so here we have our balance of, which counts all the NFTs assigned to an owner. Have the owner of, you give it a token ID, tells us the address of the owner there. safe transfer from, and that just has a couple of extra checks in here. Essentially, you just, from to which token, and then the bytes data, I think, is not. I don't think there's a specific standard in the 721 standard as to what this must contain. I think that places like OpenSea or Rarible use it. Not entirely sure for what, but I think NFT marketplaces will use this for some reason. Let's see here. And then, yeah, you can send it without the data too. Here we have approve, just like before for allowances, except it's more of a binary allowance, whether or not a particular address is allowed to send a token. And that's pretty much all that we have for the ERC 721 standard. We have events, but we'll go through events later in the course. That will be in a different session when I actually start coding. Yes, so let's look at the implementation now. Yes, name of the token, this is token symbol, same as before. Token URI, not important. Here we have our approval. We just need to, for example, make sure that we're looking at the owner of this token, etc., etc. Make sure that they are approved to transfer this token, and then you can go on. Let's see here. Transfer from. Pretty simple, just make sure they are approved or owner of this token ID. Again, require is like a test assertion where it will kill the execution, terminate the execution if this condition does not return true. Otherwise, we'll transfer that there. Yep, transfers. These are all pretty similar. The nice thing about the ERC 721 standard is it's actually relative to the ERC20 standard. I think it's a little simpler. So this should be a little bit easier to read and understand than the ERC21, just because ERC20 has a little bit more logic behind like approvals, whereas ERC 721 is just, it doesn't matter. It's either it's binary. You either have access or you don't. It's not for a specific amount. Something to note about these Open Zeppelin contracts is that they have a lot of internal functions, and these are kind of like, if you're familiar with the private modifier, theirs are similar. They're internal only, is how these functions work. Internal functions cannot be called by external functions. Private functions can be called by external functions. We'll go through the modifiers later. But yeah, it just should be noted that they have a bunch of these internal functions in these Open Zeppelin contracts that all of the public-facing methods call, instead of doing all the logic like directly inside of themselves. So like if we look at this safe transfer from, it calls _safe transfer here, which is an internal function, right? So, and then they'll use this in a couple different places. So that's just something to note about the implementations of these NFT contracts here. A couple live contracts here. Definitely recommend you look at the Rarible one, because that's a live NFT marketplace. And then there's just one issue that I want you to note here, just general inefficiencies of ERC 721s. Yeah, pretty much it's this is the big deal right here, is where you can only send one NFT at a time. And that's kind of the central complaint there. But again, it's not like any severe security vulnerability. All right, and then we have a couple other interesting contracts here. I like this double or nothing one that I found because it's really simple and straightforward. Highly recommend you read through this. The code is commented. This is a live contract. I'm not saying that you should send any transactions to it, but I would definitely recommend that you read the code because it's short, it's sweet, it's to the point, it's well commented, and it uses the safe math library, which is, I think it does. Yeah, it uses the safe math library or some derivation of it, which is a very, very popular Solidity library. So definitely recommend you check out this guy as well as, you know, all the other live contracts that we mentioned here. All right, so I am going to stop going through this material here and we will move on to presentation. So if anyone has a 2-minute presentation about a topic that we covered here, whether that is ERC20, 721, 777, 1155, fungibility, smart contracts, any of the above, maybe you found one of these tokens particularly interesting. Let's talk a little bit about the project here. So, given that we have seen two different types of, well, we've kind of gone a little bit more in depth into two different types of Ethereum smart contracts, ERC20, ERC721. I'd also recommend giving a look at ERC777 and 1155. Also 165, which is the one that that allows contracts to detect whether a contract supports or implements a particular interface or a particular ERC standard. So I'd recommend you take a look at all 5 of those, but particularly ERC20, ERC721, those are the big ones. Those are the ones you're going to be hearing about by far the most. Right. So they are. So let's see. If I look back, where did I put my slides? Here we go. If I look back at my slides, here we go. Okay. So all these 4 right here, ERC20, 721, 777, 1155. By the way, if you hadn't noticed it before, the slides are available on the website. So you go to the website, web3.courses, click on View Course, find the topic that we're on. Right now it's topic 2. Okay, then you find this sidebar. If I zoom out, this is probably what it'll look like here. So you find the sidebar here. The slides are right here. You just click on that. That's where all the slides are. Right. So, yep, look at these 4, 20, 721, 777, 1155. Those are the most important ones. If you want to dive a little bit further, then you can look at ERC 165, which is for detecting if contracts implement specific token standards, right? I wouldn't recommend reading that one if you haven't already read these 4, though. All right, so let's skip back to, here we go. Is next Monday? Yeah, I think we will be meeting next Monday. Is that an issue for people? Yeah, if people don't want to meet on the 5th, just I suppose message the Discord, and if we reach critical mass, then we can postpone it, or maybe just cancel. All right. Right. So we went through that. Perfect. All right. So for the project status update, we are going to be creating a fully functional dApp throughout this course. So here are a bunch of different ideas that you can use as inspiration for your project. Yeah, you should think about what you might want your project to look like. It must contain a smart contract and a web front end at least. If you don't have a lot of experience with front end web development, I'm more than happy to assist you with that because that is what I do for a job. I am a front end web. Well, I've been a front end web developer for 10, 11 years now. So there should be no issues in getting help in that department. Yeah. And then obviously we're writing smart contracts, so it needs to have a smart contract. It doesn't have to be complicated. Should be usable by a general audience, meaning, I mean, it's a DApp, it's a decentralized application, so it shouldn't be like, oh, only a limited subset of people are able to use this. So here are some ideas. Identity management systems and unstoppable domains is comparable to that sort of thing. If you guys are familiar with unstoppable domains, it's like the Ethereum name service, except they're trying to do it for like an alternative to DNS type of thing. You could do a lottery, kind of like the double or nothing here, a voting system or an auction, and then you can understand maybe some of the potential difficulties in implementing voting systems in electronic voting systems in governments. Let's see, savings accounts or loans, that would be an interesting one. There are some projects like Pool Together, which is kind of like a savings account where then they invest your tokens and you get back like interest essentially, except they give all the interest to a few select people, so it's kind of like a combination between earning interest on a savings account and a lottery. Kind of an interesting thing. Definitely recommend you check that out. You could do an integration with a website such as like r/cryptocurrency's Moon token, where I think it's for comments and upvotes or something like that. You get their own cryptocurrency that they minted over there. You could do escrow, an NFT collectibles game, or sports betting, or a ERC20 exchange platform. This one would be that would be an impressive thing to put on a resume. Definitely give that consideration if you have the time. But yeah, any questions about the project? So all that you need to do for now is come up with an idea. Figure out what you want to work on. Just think about the idea. Don't bother writing any code. Just think about an idea. Think what would make it cool, and maybe write down kind of like a rough sketch of what you think the project could look like for you. And if you want to work in groups, you can definitely work in groups.